All right, today we're diving into a really fascinating, kind of provocative new theory about the very fabric of reality. What if we could actually build a physical picture for some of the biggest mysteries in physics? Let's get right into it.
So, let's kick things off with one of the biggest questions in all of physics. Really, is the universe just a bunch of beautiful equations? Is that the whole story? Or is there something else? Some kind of actual, physical machinery underneath it all, A real substance that everything is made of?
This table really breaks down where we're at in physics right now. See, on one hand, we have these brilliant mathematical descriptions, these algebras of numbers, and they are amazing at telling us how things behave. But a lot of scientists are looking for something more. They want to know what things actually are. That's the real holy grail, that complete machinery.
Okay, so if you're going to propose a new machinery of reality, you can't just wave your hands. You've got to tackle the really tough, unsolved problems. And one of the biggest absolute monsters is the mystery of something called half-integer spin.
So what is that? Well, it's a property that particles like electrons have, and it is just deeply weird. Think about it. You take any object, right? A coffee mug, a ball, whatever. You rotate it 360 degrees, and it's back to looking exactly the same. Simple. But an electron, a particle with half-integer spin, you have to turn it a full 720 degrees. That's 2 full rotations to get it back to its original state. The math works, but we have no idea, no physical picture of what's actually going on there.
So how in the world do you build a physical picture for something that strange? Well, this is where this new theory comes in, and it proposes a solution that starts from a place that's surprisingly simple.
The core idea is, honestly, stunningly simple. It proposes that everything, and I mean everything, space, matter, energy, it's all just one single, continuous 3D elastic fabric, kind of like a cosmic rubber sheet. Now, right away, the big objection, and people have brought this up with similar ideas before, isn't that too simple, right? How can a basic, stretchy fabric possibly explain something as bizarre and not like as that 720-degree spin?
Well, the theory's answer is actually pretty ingenious. It's a two-part mechanism that uses the fabric's own elasticity to create a structure that's complex enough to pull it off.
Okay, so layer 1 is what's called the carrier ball. The idea is that a stable, ball-like structure, a pseudoball, forms right there in the fabric. And this is key. It's not a separate object. It's a persistent, self-contained shape made of the fabric itself.
The way this source material explains it is great. It's like blowing up a balloon. You've got to tie it off, right? You have to close it for it not to lose the air. This pseudoball is basically that, a closed, stable disturbance in this elastic reality. And here's where it gets really powerful. This one simple structure could potentially explain some huge concepts. Its stability, that could be what we perceive as mass. The way it affects the fabric around it, well, that could be gravity. And all the different particles we see in the universe, they could just be different ways this ball vibrates, different resonances.
But wait, what about the spin? That's the whole problem we started with. Well, that comes from the second layer, a dynamic process happening inside that carrier ball. The source calls it the continuous belt trick.
Okay, let's walk through this because this is really the heart of the whole theory. First, a little bit of volume inside that pseudoball starts to rotate. Then, since the fabric is elastic, it starts pulling the surrounding fabric along for the ride. This pull creates a continuous belt-like motion. And here's the magic trick. The fabric actually flows from inside the ball to the outside of that little rotating part. And what you're left with, this crazy, twisting topological motion, that is the physical model for half-integer spin. It's a real, tangible picture for that bizarre 720-degree rotation.
Now, of course, this is all just a really cool idea until you can actually test it. So how on earth do you prove something like this? Well, you try to build it in a computer. Yep, the plan is to build a computer simulation. The goal is to create a digital network of points that acts just like a continuous elastic fabric. Then you just see what happens. Can these ball and belt structures actually form? And more importantly, are they stable?
But yeah, this is way harder than it sounds. The biggest hurdle is something called the no passing through problem. Think about it. In a real fabric, threads can't just pass through each other. You have to program your simulation so that all these little digital points can't pass through each other either. And that requires some incredibly careful network configuration. It's a huge computational challenge.
But let's say you get the simulation to work. There's still one more giant hurdle.
Any new theory of reality has to play nice with the current champion, our best theory of gravity, Einstein's general relativity. So the key question is this. If those pseudoballs are what we call mass, does the way they bend this elastic fabric, does it actually match the way Einstein said mass curves spacetime? That is the billion-dollar question right there.
Well, the model has a knob you can turn. There's one key parameter, the elastic resistance of the fabric. The idea is you could tune this parameter, you could fit it until the model's predictions match what we actually see in the universe. And this leads to a really wild thought. What if that elastic resistance isn't the same everywhere? What if, in really extreme places, like near a black hole, it changes? That could mean the speed of light isn't actually constant.
So, as you can probably tell, this is a massive, massive undertaking. Which brings us to the final, very human part of this story.
So you might be asking, hey, if this idea is so great, why doesn't the person who came up with it just do the research? Well, the author is really honest about the obstacles. There are 3 big ones. Mortality, we don't live forever. Complexity, this stuff is incredibly hard. And of course, money.
And that reality leads to this quote from the author, which is just beautiful and incredibly humble. It really captures the spirit of science, how it's this long collaborative effort. He says, "I am just one old turtle standing on the next turtle, hoping for another turtle to stand on me." And we'll leave it with one last kind of witty quote from Benjamin Franklin that the author shares. He said, "It seems impossible to predict future benefits from my research, but I am sure it is going to be taxed." It's a funny but really profound point about doing this kind of fundamental research. You never know where it's going to lead. But it leaves us with a pretty fascinating thought, doesn't it? What if the deepest, weirdest mysteries of the quantum world aren't about abstract math at all, but about a reality that is, when you get right down to it, just elastic?